Welcome to the Explainer. Sometimes the biggest changes in the world come from the smallest things. Today we're talking about a discovery that literally changed everything about modern medicine. It's an amazing story, one that's all about pure chance, incredible determination, and, believe it or not, a warning that might be more important now than ever. So get this, one of the single greatest medical breakthroughs ever didn't kick off with some big elaborate plan. Nope. It started right here, with a forgotten petri dish and, well, a little bit of mold. This photo, this is it. This is the exact moment a revolution in science got started. Not with some big explosion, but with someone just noticing something.
And you heard it right from the man himself, Alexander Fleming. I love that he was so honest about it, He just admitted that luck played a huge part. But this isn't just a story about a lucky accident. It's about what happened after that moment of chance, and the absolutely massive effort it took from a whole team of people to turn that bit of luck into a genuine miracle.
All right, so let's get into it. This fortunate occurrence all went down at St. Mary's Hospital in London. And the funny thing is, Fleming was kind of known for having a messy lab. But in this one case, that messiness, well, it turned out to be an absolute stroke of genius.
So picture this. Fleming gets back from vacation, walks into his lab, and sees this petri dish he'd left out. Now, most people would have just thrown it away, right? Contaminated experiment, junk it. But not Fleming. He looked closer, and he saw something funny. A blue-green mold had grown on it, and all around that mold, there was this clear zone, a ring where the bacteria had been totally wiped out.
He figured it out pretty quick. This mold juice was basically a chemical weapon the mold was using to defend itself. So following the rules of science, he gave it a name based on the mold's own name, Penicillin. And that's how he got penicillin. He knew right then and there that he'd stumbled onto something huge, a powerful weapon against bacteria.
But here's where the story takes a weird turn. You'd think this would be front-page news, right? A world-changing discovery? But nope, it was about to get put on a shelf and just sit there for almost a decade. All that incredible potential was just locked away. I mean, he published his work back in 1929, but it barely made a ripple. He just couldn't get the substance stable, couldn't purify it, and after a while, he kind of gave up and moved on. So for the next 10 years or so, penicillin was nothing more than a laboratory curiosity. It took a world at war, with soldiers dying from infected wounds, to create the desperate need that finally brought it back into the spotlight.
And you have to understand, the challenges were just huge. Fleming even said it himself. His team, they were bacteriologists. They understood germs. They weren't chemists. They didn't have the skills to actually isolate and stabilize this stuff. The whole process was so clunky and inefficient that one expert basically said, yeah, using this as a medicine, it's pretty much impossible.
Okay, so let's jump forward in time. We're heading to Oxford now because this is where that laboratory curiosity transforms into one of the biggest scientific quests of the entire century. A brand new team picks up Fleming's old research, and this time they have a powerful motivator, a world at war.
And this is the team that made it happen. These are the guys who turned that forgotten discovery into a true wonder drug. You had Howard Florey, the leader, Ernst, the genius biochemist, and Norman Heatley, who was a wizard at making things work on a practical level. They came together at Oxford with one single focus, the Penicillin Project.
So, how does this stuff actually work? Well, to get it, you first have to know a little something about bacteria. Imagine a bacterium is like a water balloon. What keeps it from just popping? It has this tough, net-like wall around it called peptidoglycan. Think of it like a suit of chainmail armor that holds everything together.
Okay, so here's the brilliant part. That armor, that cell wall, it's constantly getting damaged, so the bacterium has to repair it. What penicillin does is it sneakily jams up the tools the bacterium uses for those repairs, so the wall just gets weaker and weaker and weaker until, pop, the whole thing just bursts. And the best part? Our cells, human cells, we don't have that wall, so penicillin is like a guided missile that only targets the bacteria, leaving us totally unharmed. So by 1941, the team in Oxford is finally ready. They have enough to test it on a person. Their first patient is a policeman, Albert Alexander, who has this horrific infection that's about to kill him. They give him the penicillin and it's a miracle. He starts getting dramatically better. But then the unthinkable happens. They run out. They use their entire world's supply on him. The infection comes roaring back, and he dies. It's an absolutely tragic story, but it proved two critical things. One, this stuff works. And two, they needed to figure out how to make a lot more of it, and fast. So now the problem has completely changed. It's not a science problem anymore. It's an engineering problem. It's not about making a tiny bit in a lab flask. The question is, how on earth do you scale this up to make enough to treat an entire army? Thousands, maybe millions of people.
Well, they couldn't do it in Britain. Every factory was already churning out things for the war. So, in 41, Florey and Heatley get on a plane to the U.S., carrying a little sample of their precious mold. And what happened next was just incredible. The U.S. government, universities, and 21 different drug companies all came together in this massive, unprecedented collaboration. Everyone working towards one single goal: make more penicillin.
And the breakthroughs they needed? They came from the weirdest places. At a lab in Peoria, Illinois, of all places, they discovered that if you fed the mold something called corn steep liquor, which is basically just a waste product from making cornstarch, the yield went through the roof. And the best, most powerful strain of the mold? They didn't find it in some fancy lab. Someone found it on a rotten cantaloupe at the local grocery store. You can't make this stuff up.
Just think about that for a second. Let's go all the way back to the beginning. It all started on this one single petri dish, a piney little accident, a speck of mold. And when you see that, and then you think about what was about to come next, the contrast is just staggering.
Because by 1943, this massive American effort was pumping out 2.3 million doses, enough for the entire D-Day invasion of Normandy. This wasn't just a drug anymore. It was a strategic weapon of war, something that was going to save an unbelievable number of lives. And to really wrap your head around that 2.3 million number, just remember how this all started back at Oxford. They were growing the first batches in literally anything they could get their hands on. We're talking bedpans, old milk churns, even bathtubs. They hired a team of 6 women, the Penicillin girls, to basically run this improvised DIY factory. To go from that to millions of doses, it just shows you how incredibly far they came and how fast.
So the success was just undeniable. Penicillin was the miracle drug. It helped win the war. But the story isn't over, because the guy who discovered it in the first place had something to say. And it was a pretty chilling prediction about the future. In 1945, the Nobel Prize came calling. And they got it right. They honored the whole story, giving it to Fleming for that first, brilliant observation, and also to Florey and Chain for leading the huge team that actually turned that observation into a drug that could save the world.
But you have to hear this. In his Nobel acceptance speech, at the absolute peak of his success, Fleming stands up and gives this incredibly scary and incredibly accurate warning. He basically lays out a scenario. What if some ignorant person doesn't use enough of the drug? He said you wouldn't just fail to cure the infection, you would actually be teaching the microbes how to resist it. And then when that resistant bug infects someone else, they die. A truly chilling thought.
And guess what? That hypothetical scenario he described, it's our reality now. The very germs he was trying to kill have learned to fight back. We now have superbugs that are resistant to almost everything we can throw at them. It's become a massive global threat. The numbers are just mind-boggling. Some experts think that by 2050, more people could die from resistant infections than from cancer. It threatens to erase all the incredible progress that started with that one little petri dish.
So this whole amazing story leaves us with a really big question, doesn't it? The miracle of penicillin, it only happened because governments, universities, and private companies all worked together. They shared everything, they collaborated openly, all for the common good, not for patents or profit. So as we face our own modern crises, things like antibiotic resistance or even new pandemics, maybe the biggest lesson we can learn comes from that little bit of mold that changed the world.